Hi, welcome to the Section 3.8 notes on parallel and perpendicular lines in a coordinate plane. So first little bit is just to make sure we have all the formulas down. You may be familiar, you should be familiar with some of these from algebra. So first of all, for slope, try and think of what you know about a slope formula. And hopefully you're thinking of either rise over run, or you're thinking of y2 minus y1 over x2 minus x1. So those are a couple of options, and we'll practice those in a few moments. You may also just think of it in words like change in y over change in x. Point slope formula is y minus y1 is equal to the slope times x minus x1. And that again is when you have a point, and that point would be x1, y1 is what you could label it, and you have the slope, then you can plug those things into the point slope formula. And then the slope intercept form is, I guess I'll label this as the slope and this as a point on that line. Okay, and the slope intercept form is y is equal to mx plus b. And again, if we think about what the parts mean there, we know that m stands for the slope, and we know that b stands for the y-intercept, which is where the line crosses the y-axis. Okay, now for some specifics about parallel lines. The basics of that, we can say a longer version. If two non-vertical lines are parallel, then the slopes are equal, and that the converse of that is also true. But let's just shorten that to say same slope. Or if you want to put slopes are equal, that is fine. Another thing I can say about it is any two vertical lines are going to be parallel to each other, and any two horizontal lines are going to be parallel to each other. You know, vertical lines have no slope or undefined slope, and horizontal lines have zero slope, and so they would be parallel. If I look at an example like y is equal to 3x plus 5, and y is equal to 3x plus 7, then I can see here that, you know, again, if I see that this is in slope intercept form and the y is by itself, I'm looking at this 3 and saying, okay, this has the slope of 3. All right, if y is by itself, whatever's in front of the x is the slope. So this one has a slope of 3. So since those two lines have the same slope, then those two lines must be parallel lines. Okay. Now, if we think of perpendicular lines, then perpendicular lines, the symbol for that is this upside down capital T. But there's a couple of different ways you can think of it. I would say that most people think of it as they are opposite reciprocal slopes. Okay, or you can think of it as negative reciprocal slope. Some people will use that term. So in that case, if one line has a slope of 3/4 and the other one has a slope of negative 4/3, then those two are opposite reciprocals. If I take that 3/4 and I flip it and change the sign, I get negative 4/3. So I would know that those two lines are perpendicular to each other, which means when they intersect, they form right angles. Another way to think of perpendicular lines is that the product of the slopes is -1. And if we think of an example of that, if we use the same examples we just talked about, product means the answer you get when you multiply. So if I multiply 3/4 times negative 4/3, I end up with negative 12 over 12, which gives me negative 1. And so, again, the product of those slopes is negative 1, so therefore I know those lines must be perpendicular to each other. I can also think of that as any horizontal line and vertical line would definitely be perpendicular to each other. Okay. And again, same thing that I'm just kind of running out of room here, but same thing I did with the parallel lines a minute ago. If y is by itself, I can tell what that slope is because it's the coefficient in front of the x. So I just showed you an example here. I guess to show you one other example, let's see, if I had a slope of 2, then the opposite reciprocal of that would be negative 1/2. Okay, I can make 2 a fraction by putting 2 over 1, and then I can flip that fraction and change the sign and get negative 1/2. If I start off with a negative slope and I flip it and change the sign, it becomes a positive slope. So hopefully you get the idea there. All right, here we go. So as we go through these notes, we are just going to do the odds together right now, and then I'll be done with the video. You can either do the evens as we go through the video now as practice, or I will have you do them as the warm-up at the beginning of class when you come in on the next day you come into class. I would have you working on those as I'm taking attendance and coming around to check your assignments. So again, but if you prefer to do them now, kind of right after seeing an example right beside it, that's fine. But if you want to wait till class day, that is fine as well. All right, so on example 1, it says, in exercise 1 and 2 are lines M1 and M2 parallel and explain. Okay, we're not going to just answer that question by looking at the lines and kind of deciding, oh, do they look parallel or not? We want to know for sure. So you need to find the slope, and you need to include the slope in your answer. You can either find the slope by rise over run, or you can find it by the slope formula. So I'll do one of each just to give you practice, but then you can just decide which you prefer. So if I go ahead and find the slope of M1 here on the left, I'm saying how far do I go up from here to here, and I can just count that. Remember, you're allowed to count in the horizontal and vertical on a number line. So I can count up 1, 2, 3, 4, 5 to get even with the other point. And now I'm going this direction, and I went 2 to the left, so I'm going to call that negative 2. So when I try to find the slope of M1, then I'm going to write down my formula that I'm using. I'm doing rise over run, and I just went up 5 and then left 2. So I got a slope of negative 5/2. Okay. Now I'm going to show you finding the slope of the other line. I'm going to find, I guess I don't really like this M1 thing. I'm just going to call that M1 to represent the slope. No, I guess those are the lines. Okay, I'm going to switch that again. Okay, so this is my slope. And I'll just go ahead and include that M1 there. It just looks a little weird. All right, now if we move on to the next one, and I want to find the slope of line M2, then I'm going to go y2 minus y1 over x2 minus x1. And sometimes that is helpful for people to go ahead and write down what the ordered pairs actually are. So one ordered pair is -1, 6. And the other ordered pair is 1, 2. So if I want to label these points, I can label one of my points x1, y1. And the other one I can label x2, y2. So when I plug those in, I can subtract the y's, so 2 minus 6. And I can subtract the x's, 1 minus -1. And that gives us -4 over 2, which is -2. Okay, so in this particular case, I need to look at my two slopes. Here's the slope I got, and here's the slope I got. And I need to now answer the question, are lines M1 and M2 parallel? So again, I have to think parallel lines have the same slope. These two slopes are not the same. So that's what I need to respond. I need to say no, M1 and M2 are not parallel. But do not stop there. It says explain. Even though I've written some words here, I have not explained anything. I need to say because they don't have the same slope. Okay, and I could even go further to say like -5/2 is not equal to -2 or something like that. This 2 down here didn't show up very well. Try and fix that. Okay, so -5/2 is not equal to -2, so that would be an additional way to show more information about that. Okay, so you'll do number 2 later on your own and try that. All right, then on number 3, it says write an equation of a line parallel to line AB that contains point C. So in this case, we're talking about 2 different lines here, okay? This y equals 1/5 x plus 8 4/5, that is one line we're dealing with. And then there is a line AB that goes through point C and goes through the point 3,6. Okay, so first thing I need to do is look at the equation on the left. Again, it's in slope-intercept form. And when it's in slope-intercept form, I can easily tell the slope because it's whatever's in front of the x. So in this case, the slope is 1/5. So if the 2 lines are parallel, then the slope over here on the right of this line has to also be 1/5 because we just said parallel lines have the same slope. So now I know the slope of this line on the right, and I know that it goes through the point 3,6. And so now I could just plug that into my point slope formula if I want to. Here's my x1. I can label this x1, y1. And when I do that, then here is my equation. Y minus y1 is equal to slope times x minus x1. So that's my point slope formula. And now if I go ahead and plug in, I've got y minus, my y1 is 6, is equal to the slope, which in this case is 1/5. And then times x minus x1, which in this case is 3. Okay, so that is my equation in point slope form. If that is what it asks for. If they ask for it in slope-intercept form, which is y equals mx plus b, then you would just need to distribute the 1/5 and add the 6 over to get y by itself. So just kind of pay attention to what is being asked for. But in this particular case, we're just going to leave it in point slope form. All right, moving right along. Okay, in exercise 5 and 6, it says our lines M1 and M2 perpendicular. So again, we need to find the slopes of these 2 lines, but we need to then compare those slopes and answer the question. But the first step is finding the slopes. So I'll do the same as last time. One of the slopes I will find by rise over run. So in this case, I'm rising up 3 and I'm running 2. So my slope of M1 is, again, rise over run, which in this case is up 3 over 2. Okay, so then for my next line, if I want to find the slope of M2, I can do my y2 minus y1 over x2 minus x1. And again, one of my points I'm going to label x1, y1. The other one I'll label x2, y2. So when I plug that in, if I subtract the y's, then I've got 4 minus 0. If I subtract the x's, I've got -4 minus 1. And I end up with 4 over -5. So in this particular case, now I can look at these two slopes, and here again is a slope of 3/2. Here's a slope of -4/5, and I need to determine, are they perpendicular? Remember what we said on the first page, perpendicular lines have opposite reciprocal slopes. So if I take that 3/2 and I flip it and change the sign, I would get -2/3. And in this case, I did not get -2/3, so these lines are not perpendicular. So again, I need to answer the question. I can say in this case, no, the lines are not perpendicular. And then again, don't stop there, because the slopes of 3/2 and -4/5 are not opposite reciprocals. Or you can call it negative reciprocals, or you could say no, because the product of the slopes is not -1. And you could show that you are multiplying those and that you don't get -1. Okay. All right, moving right along. If we go down to number 7, it says write an equation of a line perpendicular to the line that contains point P. So again, we're going to write this in point slope form. So I'm going to write that here. So we're going to leave our answer in point slope form. And in this case, again, we're dealing with two different lines here. I like to draw a line to kind of separate what's going on. Here is one line over here that's in slope-intercept form. And when it's in slope-intercept form, I can easily find the slope, because it's when y is by itself, it's whatever's in front of the x. So in this case, it is 2. Okay, but that means that the slope of the line perpendicular to this one is, again, if slope of 2, that's the same thing as 2/1, if you want to put a 1 under that. And if I flip that and change the sign, then I end up with a slope over here of -1/2. Okay, again, if I want to go and label this ordered pair as x1, y1, then again, my point slope formula is y. That's not showing up very well. Okay, so I've got y minus y1 is equal to slope times x minus x1. Okay, so if I go and plug my information in, then I've got y minus y1, which is 5, is equal to the slope that we just said is -1/2, and then times x minus x1, which in this case is -6. Again, I don't like leaving that negative there, so I'm going to rewrite this. So y minus 5 is equal to -1/2 times x plus 6. Kind of cleans it up a little bit. So again, that's my answer in point slope form. If for some reason they ask for it in slope intercept form, you could distribute that -1/2 and then add your 5 over, and you'd have it in slope intercept form. So you can interchange those easy enough. Okay, almost done. 2 more. So on number 9, it says rewrite the equation in slope intercept form, then determine whether the lines are parallel and to explain. So again, slope intercept form is our y is equal to mx plus b. Okay, in this particular case, if I want to get this top equation where it has y by itself, I can divide by 2 on both sides. And when I do that, then I end up with y is equal to whatever's in front of the x. If you don't see something there, it's technically a 1. So I actually have 1/2 x and then plus 15/2. Okay. And so I can see that the slope of this particular line is, again, if y is by itself, whatever's in front of the x is 1/2. Okay, now I'm going to look at the other equation, and I want to get y by itself for that one. So to get y by itself there, I'm going to go ahead and keep the y where it is and subtract the 5 on both sides. So when I do that, I've got x minus 5 is equal to 2y. And from there, if I go and divide by 2 on both sides, then again, in front of that x is a 1, so I can say 1/2 x minus 5/2 is equal to y. Okay, so in this particular case, again, since y is by itself, whatever's in front of the x is the slope. So I get a slope of 1/2. And to answer the question, determine if the lines are parallel. And to explain, I can say that yes, yes, the lines are parallel. Because they have the same slope. Of 1/2. Okay, so last one is number 11. And on number 11, it says write each equation in slope-intercept form, then determine if they're perpendicular. So similar to what we just did. Then in this first case, again, we're trying to get it in y equals mx plus b form. So in this first equation, if we go ahead and add 1 to both sides, then this equation becomes y is equal to negative x minus 5. That doesn't look like a 5. Let's fix that. Okay. So y equals x minus 5. So in this particular, okay, y equals negative x minus 5. So in this particular case, again, when y is by itself, the slope is whatever's in front of the x. And so in this case, if you want to think of it as a negative 1, then I have a slope of a negative 1 here. All right, next is I can get y by itself for the next equation. So I would go ahead and distribute this negative 5/6 first. So I've got negative 5/6 x, and then the negative times negative becomes a positive, and so I end up with 25/6 there. So when I go ahead and try to add that 3, okay, over here, when I try to add 3, then I realized that I actually need it in 6 to be able to combine those together. So instead of writing plus 3, I'm going to write plus 18/6. It means the same thing as 3 because 18 divided by 6 is 3, but it has a common denominator with the 25/6. So from there, I've got y is equal to negative 5/6 x. And that is plus, if I add this 25 and the 18, I get 43/6. And so again, in this particular case, I've got the y by itself, and then again, whatever's in front of the x is the slope. So in this case, that is the slope of this one. Up here, we said the slope is -1. And again, we're trying to decide if the lines are parallel or not, and they are not perpendicular. They are not perpendicular because their slopes are not opposite reciprocals is one way to say it. Again, if I take that negative 5/6 and I flip it and change the sign, I would get 6/5, and that's not the same thing. Or if I take -1/1 and flip it and change the sign, I would get a slope of 1, and that's not the same thing. So I just need to answer the question now. So I need to say no, the lines are not, I'm going to use the perpendicular symbol because the slopes of -1 and -5/6 are not opposite reciprocals. Okay. Or you could say the product of the slopes is not -1. So again, just make sure you're answering the full question and explaining. And I think it's helpful to actually put the slopes in my response to make sure it shows that I did that work. So, all right, thanks for signing on. Let me know if you have questions. And like I said, you'll practice the evens tomorrow, so you'll get better at doing them yourself, and you'll have these as examples.